All right, so today we are going to review what we've been doing the last 2 days by doing number 3 together. And then we're going to move to the new stuff on the back. So number 3, here we go. What is the domain of this quadratic going to be? Good. Always negative to positive infinity. Nothing is stopping it. Okay. What do I need to determine the range of any quadratic? You have to know the what first.
The y.
The y of what?
Of that vertex.
Of the vertex. We have to know the y of the vertex first. Okay. So the vertex is down here. What is that point? Looks like it has an x of 2, right? And a y of 1, 2, 3, negative 4. Right? This is the point 2, negative 4. This is our vertex. Now we can answer the range, right? All of the other y's, are they above or are they below that negative 4? They are all above, so we're going to say greater than. Good. When parabolas open up, our y's are getting greater. When parabolas open down, our y's are being less. Okay, so the way it's opening tells you if we're greater or less. All right, what do you want to do next? The end behavior? Okay. All right, so we have a left side and we have a right side. Negative infinity for x is our left. Positive infinity for x is our right. Where is my function going on the left and the right side? They're both going up, which we're going to say positive infinity. Good. All right. Now what? X-intercepts? Yeah? Okay. So we're looking at where it's crossing the x-axis. Remember, these are x's. These are y's. We got 2 spots. Where are those at? 1, 2, 3, 4, 5. Yep, 6. So how do I write that? Negative 2, 0. Yep, and 6, 0. Good. All right, let's go ahead and do the y-intercept. We're here. Why not? So remember, my y-axis is going up and down. It's crossing over right here. What is that point? How do I write that for the y-intercept? There you go. Good. All right, what would you like to do? How about axis of symmetry? That's not the whole answer. If you just put 2 right here, we're wrong. X equals 2. Good, yes. It's the equation of a line. X equals 2. That whole line cuts our parabola in half. Good. Remember, that matches the x value in my vertex. And it's also going to help me with my increase and decreasing intervals, right? We start at negative infinity. We're going to walk down. There we are. There's Olivia. She's going to walk across the parabola, okay? Is she increasing or decreasing first? She's decreasing first. When does she stop decreasing? When she hits the, that should be positive. Yeah, when she hits the x value of 2. Remember, we walk from left to right. We're walking across the x's, okay? It wants to know, is my direction going up or down? So as I move from negative infinity and I reach the x value of 2, we are decreasing. And then as we continue to walk, after we leave 2 and we continue to walk to the right, we are now increasing. We're climbing up the hill. Okay. This was the same thing from Monday, the same thing from Tuesday. Your front pages on all 3 days is the exact same thing. Because I'm not giving you an equation, I'm giving you an actual graph. If you get a graph, it's done the same way. Okay. Now we're going to use the back. Okay. On Monday, we had standard form. Let's scroll. Okay. Here we go. On Monday, we had standard. You don't have to write this down. I just want to show you. We worked with ax squared plus bx plus c on Monday, right? The c was your y-intercept. Your opposite b over 2a gave you the axis of symmetry, which we got to use to plug in to find the rest of my vertex. The a value told you positive or negative, if it's opening up or down. Different pieces of it gave us different things, okay? Yesterday, we did factored form, right? Where it was already factored for us. Because on Monday, we had to do factoring to find the x-intercepts. Yesterday, it was already factored. So we could go ahead and pull out the p and the q, changing its sign, right? If it was negative, now it's positive. If it was positive, now it's negative. To find our x-intercepts, the a value still told you if it opened up or down. Right? We multiplied the a, p, and q to get the c value or our y-intercept. Okay, so different pieces gave us different information yesterday with factored form. Okay.
Is that x for the b?
Yep. All right, today we have vertex form. So what do you think is going to be given to me in this equation? The vertex, yes. Okay. All the other ones, we had to find x, plug it back in, and find y, right? I don't have to do that this time. It's already in vertex form, excuse me, okay? So our vertex is going to be HK. Look at the equation. See how it has minus H in the parentheses? Okay? But we need positive H or the opposite of H when we pull it out. Just like my x-intercepts yesterday. When you pull things out of parentheses, you have to change their sign. Okay, so H will always change its sign because we're pulling it out of parentheses, right? Your plus K on the end doesn't change. It's not in parentheses. It's fine, right? Your A value out front still tells you if it opens up or down. So if you have a positive out front, it'll open up. A negative out front, it'll open down. All right? So if we are given the vertex, that means we're given the axis of symmetry, right? It's going to be x equals h for axis of symmetry. If we already know what the vertex is, then we know what line cuts it in half. Finding our x-intercepts today is going to take some work getting x by itself, but you're going to be fine. There's not factoring involved. It's more like moving things over. You got to move the k, divide by a. There's going to be square roots involved. Okay, but it's not factoring. It's moving things over. All right, ready to do some? Here we go. Let's start with 5. Okay. We have the equation f of x equals -3 times x plus 2 squared. And I don't have a k on the end, but the equation I just looked at has a k on the end. So what do you think our k is? No. Going back here. Look. Plus k should be added on the end outside of my parentheses, right? I don't have one written. So what do you think it is? No, because I would write plus 1. That would change the equation. So what could I put that wouldn't change the equation? Plus 0. There we go. Yes, should be a plus 0. Okay, so if that piece is ever missing, put it there. You need it. You need your K because I need it to find my vertex. The vertex for this problem is going to be -2, 0. We pull this out and change its sign, and then we have our 0 on the end. So our vertex is -2, 0. Okay, that's what these equations give you. right, what do you want to find next?
No, do the end behavior.
How about we do, okay, well, to do in behavior, I have to know if it opens up or down. Well, we can do it. Does it open up or down? How do you know that? There we go. There's a -3 out here. So, yes, it does open down. So that means my left side and my right side are both going towards negative infinity. Good. Let's not do it just yet. Let's do domain, range, and our increasing and decreasing because I have the vertex, so I can do all of that with that information. What's my domain? There you go. Always negative to positive infinity. My range, these are my y's. There you go. Less than or equal to because we're going down, right? So my y's are getting smaller. And then the y value of my vertex is 0. Yes. Yeah, that's technically the same thing. Okay. Yeah, let's do increase and decrease. So if you want to draw yourself a little sketch, it's going down, right? So negative infinity to positive infinity. And what's this x value in the middle? -2. There you go. So if it helps to draw a little parabola to help you out, do it. All right, if we walk across, are we going to increase or decrease first? We're going to increase first. So from the beginning to our x value of -2, we increase. And then as we move forward from -2 to forever, we're going to decrease. Okay. Ready for x and y intercepts? Yeah? Okay. So to get x-intercepts, we need x to be by itself, correct? So if I have our equation, I'm going to say y equals -3 x plus 2 squared plus 0. Okay? I want x by itself. So if there's a loose number, that plus 0, if it was something else, we would move it to the other side, right? If I subtract 0, it's not going to change anything, correct? We just have -3 x plus 2 squared. I'm going about this the wrong way. If I want an x-intercept, the y has to be 0, right? So we're not going about totally wrong. It just needs to be equal to 0. I was like, there shouldn't be two variables here. Something's going on. Y needs to be 0 because it's going to be something 0, right? Something 0. There we go. That makes more sense. All right. What is in front of my parentheses? That -3, it's being multiplied, right? So we're going to divide -3 over. Well, what's 0 divided by -3? Just 0. Okay. Now I have my parentheses being squared. This will always happen in factored form. So after we move the k, we divide by a. You will always do the square root next. Okay? You have to do the square root to get rid of our square. So if I square root both sides, well, what's the square root of 0? That's nice. So we have 0 equals, and now this is just x plus 2. So what's our final step to get x by itself? Minus that 2. So we get x equals -2. So there's only one x-intercept. What is that x-intercept? How come there's only one? Where else do you see -2, 0 up there? Our vertex. Our vertex is sitting on the x-axis. So that special case is when we only have one. Okay. I'm going to scroll down and plot what we have. Is that okay? So 2, 0. Let me come down here. So negative 2, 0 is our vertex. It's also our x-intercept. Negative 2, 0. We know it's opening which way? We said down. So we know it's going to go down somewhere. But what else do I need to finish my graph? You need your y-intercept. So we know it's going down, but I don't know where exactly it's going down. Okay. So to get my y-intercept, we want x to be 0, right?
Can one of these have no y-intercept?
There will always be a y-intercept. Good question. Yep. Every quadratic always has one y-intercept. Good. So if I want x to be 0, I'm going to take my original equation, and instead of last time making y 0, now I'm going to do it the same thing I just did, but I'm going to make x 0. So what was it? It was y equals negative 3. What is it? X plus 2 squared. So now I'm going to make it 0 plus 2 squared. So this is how we find the y-intercept. Okay? You make your x value 0, right, Savannah? Now we're going to do order of operations, Natalie. Okay? Right, Kaylee? Please excuse my dear Aunt Sally. Parentheses first. I see a 0 plus 2. So what's 0 plus 2? 2. Excuse, that's an E for exponent. What is 2 squared? It is 4. And then my dear is for multiply and divide. I see multiplication going on. What's negative 3 times 4?
12.
Negative 12. Okay. I don't need Aunt Sally. There's no adding or subtracting, right? What's up? No, because that would give you the x-intercept. If you want y, then only y can exist in the equation. Yeah, if you want x, only x can exist in the equation. All right, so we're going down to negative 12, which kind of goes off my grid because it only goes down to 10, right? 10, 11, 12, we can call it right here. If you want to do the mirror point, I can go 2 to the other side. So is that going to be negative 4, negative 12? That's the mirror image. And so it looks like this. Like that. If you wanted to count your graph by 2s to make it fit, you can. But it just barely goes off. Do y'all get how I do the mirror image, by the way? No? Some yes, some no? Okay. So what I do is I see where the vertex is. I noticed that this point on negative 12 was 2 away from the axis of symmetry. So I just went to my mirror in the middle and went 2 the other direction. So if this is at negative 2, I can go backwards 2 to negative 4. All right, so 0, negative 12. All right. Does it make sense it's opening down? Antonio, does it make sense? It makes sense? Because of that negative, right? Does it make sense that it was like really skinny and long? What piece told us from the beginning, do you think, that it was going to be skinny and long? What number? The 3. The 3. The whole thing being multiplied by 3 is what is stretching our parabola. Okay, so your A value also stretches it or it compresses it. If that A value is like a 1/2, think of it as like altering the slope. Okay, if we multiply by 3, my slope is getting bigger, so it's going to be what's it called? It's going to rise faster than it runs. Okay, if it's a fraction less than 1, it's not going to move as fast. It's going to be compressed and be wider. Okay. So look at number 8. Your number 8, you should expect to open up, right, because it's positive. And that 2, you should expect it to be tall and skinny. Okay. Your number 7, you should expect it to go down, but it's not going to be stretching in any sort of way. Okay. All right, number 6. Here we go. All right, so we have a times x minus h squared plus k. I don't have an a value here. What is it technically? Not a 0. Multiplied by 1 is not going to change it yet. So that means it is going up. Yep, because our a is a positive 1. Which tells me both of my ends are going to be positive. Good. Okay. Let's pull out my vertex. My vertex is HK. Remember, H is in parentheses. I got to pull it out and change its sign. So what is our H value? It's going to end up being a positive 6, right? Negative 6 is in the parentheses. When you pull it out, it becomes a positive 6. And then my K value on the end is negative 4. Okay. Remember, this is x minus h, right? So h is 6. All right. What do you want to do next? Domain and range. Okay. What's our domain? Same thing as it's always been. All right. My range are my y's. So we see the negative 4. Is that the highest y or the lowest y if it's opening up? If it's opening up, that's the lowest, right? So are all of my y's bigger than or less than that negative 4? Greater than. Oops, I forgot the symbol. That would help. There we go. It's opening up, my y's are going up. It's opening down, my y's are going down. You can, yep. Yeah, because we know that halfway point, right? We know this is 6. So yeah, we can go ahead and do that part if you want to. So my first half, negative infinity to 6, are we increasing or decreasing? There you go, we're falling down first. And then from then on, we increase. Good. All right. So all of that happens just by looking at the function. Really don't have to do any computing yet. Okay, your computing for vertex form is finding your intercepts, making x0 to find y, making y0 to find x. Okay, that's like the algebra you have to do for these problems. All right, which one do you want to do first? You want to make x0 or make y0? Make x0. So that means you want to find your y-intercept. Okay. So if the y is the only thing there, then you're finding your y-intercept. All right. Please excuse my dear Aunt Sally. So please, parentheses, what is 0 minus 6? Negative 6. Now we're going to do exponent. So what's negative 6 squared?
No, it's positive.
Positive 36. My dear is not there. I don't have any multiplying or dividing. That Aunt Sally, I got some subtraction going on, right? What's 36 minus 4? 32. So my y-intercept is at 0, 32. Okay. Now, well, you have to make y0 to find your x's. X minus 6 squared minus 4. We have to make our y0. Okay. Let's do green. So this is y-intercept because I have the y. This side's going to be our x-intercept because we have our x in there. Okay, so now we're pulling things away, right? You see how it's all bunched with the x? I want the x by itself, so pull things off. So I need to move negative 4 first. How am I going to move it over? We're going to add the 4 to the other side first. So 4 equals x minus 6 squared. There was nothing being multiplied to these parentheses, so I don't have to divide by a. There is no a. I mean, if you want to divide by 1, go for it. It's not going to change anything, right? So now what do I have to do? What's keeping all that? We have to take care of the exponent. How do I get rid of a power of 2? We do the root of 2. Good. What is the square root of 4? And
16.
square root of 2. Square root of 4. So yes, that's one of them. How about negative 2? Don't most parabolas cross over in 2 places? Yes. The one above this was special because my x-intercept was my vertex, right? So we only got one answer. But most of the time, this is going to happen. We're going to square root a value, get the positive and negative, and then we're going to get our 2 different x-intercepts. Okay? Because from here, I'm going to have to add 6 over, right? Over here, I get x equals 8. But when I add 6 to negative 2, we get x equals 4. So there's my 2 x-intercepts. So we have 4, 0, and we have 8, 0. Yes. So we're going to plot our points and make sure our math makes sense, right? Because if my vertex is not in between those x-intercepts, we messed up and we need to go back. Okay. We got some large numbers here. Would we like to count by 4s? Is that okay? Because of that 32 to make it fit? All right. So let's go down here to number 6. What was the vertex? 6, negative 4 was the vertex. What was the y-intercept? And then our 2 x's?
4
And 8. Okay. So those are our key pieces that we need to graph, right?
Yep.
If you want to do the bonus mirror image, we can do that later. But these are the 4 we absolutely have to plot. Let's count by 4s. So 4, you can't see black on black, can you? Let's do orange. Okay. 4, 8, 12, right? Negative 4, negative 8, negative 12. We get how we're going by 4s? Okay. My vertex has an x value of 6 and a y value of negative 4. So we're going to be in between 4 and 8, and we're going to go down 1 unit to negative 4. So this has an x of 6 and a y of negative 4. That's hard to see. Try to do red. Was red easier to see? Six, negative 4. Try green. Okay. Is that better? Kind of? You get it. Okay. So we're in the, remember this is 4 and this is 8, right? So in between 4 and 8, that's my 6. Okay. And then we went down to negative 4. So that's why this point is right here. All right. And we're doing this because my y-intercept is going to be all the way up here at positive 32. So we have 4, 8, 16, 24, 28. Here is 32. Did I skip 12? I don't know. 4, 8, 12, 16. Oh, probably. 20. I skipped a couple of numbers. Okay. 24. That would make more sense. Yep. 28. 32. Thank you. Coffee hasn't kicked in yet. Appreciate it. And that's why it helps to label. I can do the mirror image. So see how this is like in the middle? It went 1.5 over. I can go 1.5 over to this side. That's how I do the mirror image. Again, that's bonus. You don't have to do it. It's just an extra point to help your parabola. It's not like bonus points. I don't want to confuse you. It's just an extra point to help you with your shape. All right, where were my x-intercepts? 4 and 8. That doesn't make sense, does it? Oh, that's not 8. 4 and 8. There we go. Does that make sense? Is my vertex directly in the middle of 4 and 8? Yeah, it's 6. 6 is directly in the middle of 4 and 8. Remember yesterday we got to use our x-intercepts to cut them in half to find the vertex? Right? That makes sense. My x-intercepts make sense. And then we can make our U like that. All right. Okay. So you are only responsible for number 2, number 7, and number 8. All right.